Is everybody good? So you need to just move on to 5.4. So it's another short lesson. Okay. So I'm skipping 5.3. Does everybody see that? When you look at your web assignment, there's no homework for 5.3. So I am not going to do inverse function. The inverse function they cover here is just like a college algebra that you just, change your x to y, and then you solve for x, and you change back into y as f of inverse. That's what does it about in 5.3. So I don't feel like it's really worth of having that as a lesson since we don't have that much time left, because we have to take chapter 5 exam. We got to take final. So final is on 25th. That's the last day of the semester. So all your work needs to be done by 24. Actually, chapter 5 work needs to be done by 23rd, and your exam is in 24, and your final is in 25th. So you need to start working on your final review. So let me look at that one actually. I want to go over that before we do this. Okay, so when you look at it right here, chapter 5, I'm covering 1, 2, and then 4 through 8. And then you can see you have this final exam review right here. So that is due by 24. Okay, it's a 24. So you need to start working on this because I will choose your final exam from final exam review problems. So if you have not done your final exam review problem, you're going to have a problem doing your final, because your final exam comes from your final exam review problems. All right. So let me go over there. Then let's do our lesson 5.4, exponential functions and differentiation and integration. So develop properties of natural exponential functions, differentiate natural exponential functions, integrate natural exponential functions. That's the objectives of a 5.4. So natural exponential function, let's look at their relationship. The function of f of x equal to natural log of x is increasing on its entire domain. It is true, as you can see. This right here, it's increasing. Entire domain. Right? It's keep going up. So it's increasing. That's your natural log right here. All right, now let's look at that. Therefore, it has an inverse function, f of inverse. That's how you write down your inverse function. So this natural log of x is an entirely increasing function. That means, yes, it will have inverse function. All right, so domain of f inverse is a set of all real numbers. And the range is a set of all positive real numbers, as is shown in 5.18. So in other words, this one right here, that's the inverse function. So inverse function is e to the x. So you know they're inverse because you can look at it. I can draw a line through this. Y equal to x. They're mirror image. The function and inverse function, they're mirror image through y equal to x. The line going to the origin, they're inverse. They're the inverse function that they're mirror image to each other. So you just figure out the f of x. If f of x is natural log of x, then f inverse of x is e to the x. All right, they're inverse to each other. Next one. So when you decomposite those two functions, when you composite f and f inverse, okay, you get an x. So natural log of e to the x, that means x times natural log of e. Natural log of e is just equal to 1. So that's why you get x. All right, now let's look at the properties. So now you can see it. We know when the inverse function of a natural log function is called natural exponential function. It's defined like this. So that means if I rewrite this problem as y equal to e to the x, so which means I'm saying y is the same as f inverse of x. Okay, that's what I mean here. If I write it down like this, then I can say y equal to e to the x if and only if x is equal to natural log of y. Okay, because it makes sense. Look at this, y equal to e to the x. If I place natural log in the front, then you get natural log of y is equal to natural log of e, and then put the x in the front, right? And natural log of e is equal to what? 1. So you get an x. So natural log of y is equal to x. So that's how you know it. Okay. So this is a relationship. So you know it. Natural log of e to the x is the same as x. E to the natural log of x is the same as x. Okay. Remember this combination. All right. So we're gonna use that property to solve this. 7 equal to e to the x plus 1. Since we cannot solve as is, so we're gonna place natural log in the front of that. So I'm gonna put natural log in here, natural log over here. So you have this. All right, because this is exponent, so I can put that in the front of the natural log like that. Then you know natural log of e is the same as 1. So I just have x plus 1 times 1, which is same as this. All right. So now you know, you subtract 1 here and 1 here, then you get this. X is equal to negative 1 plus natural log of 7. So it's when you put that in your calculator, that is equal to this. Okay. Next thing, you know about the same base. If you have a same base, you can combine them together. Since it's the same base, the operation of exponential functions, let a and b is any real numbers, and you can say if the e and e is the same base, since it's the same base, I can combine as 1, and I can add those two powers. The same thing here, since it's the same base, e, then I can make that into e to the what? A minus b. Numerator power minus denominator power. So remember this. So you can apply that to do your problem. Next one, let's look at the properties. Okay, properties of natural exponential functions. Domain of f of x equal to e to the x is negative infinity to positive infinity. As you can see, your function is going all the way like this. All right, but the range is where? Range starts at 0 to where? Infinity. All right, function f of x is a continuous and increasing and one-to-one entire function. The graph of f of x equal to e to the x is a concave upward entire domain. This is a concave up. That's a concave up. So this is a concave up. And the limit x approaches negative infinity, that goes to 0. Limit limit that x approach to infinity, which means this one right here, the limit x approach to infinity of this function is infinity, and the limit x approach negative infinity of f of x is equal to 0. So that's where you're approaching right here, 0. Derivative of exponential functions. So that's also, it's easy. Derivative of e to the x is e to the x. You will like this, right? And then derivative of e to the u, for example, like say if I give you f of x equal to say e to the 2x, all right? Then f prime will be e to 2x times 2, because you will take derivative of this. You're going to call it u to the 2x and du to be 1, 2. So your answer will be 2 times e to the 2x. That's what they mean by this. All right, so let's look at the example. So right here is example. So you can consider that to be your u. And you're going to say du is equal to what? 2. So you have 2 right here. That came from this one. All right, next one, you have this, and you're going to say u to be this, which you can rewrite it as negative 3x to the negative 1. And then du would be negative 3 times negative 1 x to the negative 2, which means 3x squared, negative x squared, so 3x squared. So that's where that came from. All right, so nice about e to the x. E to the x, derivative of e to the x is e to the x. Derivative of e to the u stand for its composite function, okay? It's not just x, it's more than x. It's x. The coefficient is more than 1, and x has more than itself, like x squared or 2x minus 1. That's what u is. It has more than one term. And then if you have a one term, the coefficient is just more than 1. Okay, that's what u is. In this case, you need to do a little more work. Since you got two functions, you need to do u and v product rules. Okay, you gotta use product rule. So let's do this problem in our notebook. Let me write that down, problem, so I can do that problem with you. All right, I'm gonna show you my notebook so we can share the notebook. All right, let's look at the 5.4. So I'm doing an example of take a derivative of this. All right, so we got a little more work. So first thing first, let's say this is my f. That to be my g. All right, so I'm gonna do my f first. So f is equal to x squared. So f prime is 2x. So g is equal to 2 to e to the x. So g prime is what? Also e to the x. So now we can do it. Remember, if we have the product rule is, so if I take a derivative of this, I get f times g prime plus g times f prime. By the way, by now you should know this, right? Because we're using this over and over since chapter 1. So I just want to rewrite it now. So I'm going to do f times g prime plus g times f prime. So my f is x squared. My g prime is e to the x plus g e to the x f prime 2x. So we can combine this. When we combine, you get an x. E to the x is a common factor, so I have x squared plus 2x. So we're done. All right, so let's look at another example. Another one was derivative of e to the 3x, everything over e to the x plus 1. All right, so we're gonna we're gonna say I want my numerator to be my f, and I want my denominator to be my g. So we're gonna write down what they are. So f is equal to e to the 3x. F prime is equal to e to the 3x times 3. So you take a derivative of this, which is 3. So I'm going to just rewrite this. That really means 3 times e to the 3x. Let's do g. G is equal to e to the x plus 1. So g prime is equal to just e to the x. Okay. Now, what's the derivative of quotient function? It's g squared, g times f prime minus f times g prime. So we're gonna just apply that. So that is equal to g squared, g times f prime minus f times g prime. So my g prime is, the g squared is e to the x plus 1, and I'll square that. G is e to the x plus 1, and times f prime, which is 3 times e to the 3x, minus f e to the 3x times g prime e to the x. All right, so we can just combine this. So my numerator, my denominator, I'm going to just write down my denominator, their square, and the numerator. So I guess I can bring out the common factor. That is a common factor, so I'll bring it out in the front. So what is left with? So I have 3 times e to the x plus 1 minus e to the x. All right, so I can just combine them a little more. Can FOIL that. So 3 times e to the x plus 3 minus e to the x. So that is just equal to 3 minus 1, which is 2 e to the x plus 3. And we're done. All right, any questions from so far? So I am not doing anything new. We have learned how to do product rules. We have learned how to do quotient rules. I'm just using exactly same rules with exponential functions, but exponential function happen to be very easy way to take derivative because the function itself is a derivative. So which is very good for you because you know exactly what to do. You don't even have to do any extra work. The function itself is your derivative. If the functions, the e to the x, if the u part is composite function, which is more than one term, then you need to make sure you take a derivative of u. You gotta have a derivative of u. That's the part that you need to pay attention to. Other than that, it's a very simple way to take a derivative, easier than regular polynomial function. So is everybody good? Anybody have any questions? All right, so we can move back to our lesson here. So we have done this. So you know how you got all that. So integrals exponential functions. So since we know, remember derivative of e to the x is e to the x. So in other words, if I take antiderivative of that, would it be what? Same thing again. All right, same here. So derivative is happen to be same as regular function. So if you take antiderivative, would be what? Regular function also. Your original function, that's what I meant to say. All right, so this is a good example right here. So I can say my u in this case, my u is equal to 3x plus 1, and du is equal to 3. So if I need a 3, if I have a 3, then I can just simply take a derivative of this. So I'm going to multiply. So I will multiply this by 3 and divide by 1/3. Then I have 1/3 e to the u du. That means I'm done. Then I just put u, which is this. So we're done. All right. So that's it. So that's it for today's lesson. So we can move on to our homework problems and see any of the homework problems that we can go over. Okay. So let's go over this problem together. Okay. So let's go over this. As you can see, this is just simply, okay, so this one you can just say x is e to the natural log of x really means same as what? It's a 55 really means x equal to 55 because natural log and e, they're inverse to each other. So x is just equal to 55. In this case, you need to just put what? You just put the natural log in the front, right? And you get x is equal to natural log of 12. So this is easy to do also. This problem, you need to make sure you need to write this problem as x plus 3 to the 1/3 power equal to 2. Okay? And then I need to get rid of a natural log. So I need to put the e underneath. And they cancel out as inverse to each other. So you have x plus 3, 1/3 equal to e to the square. So I need to get rid of 1/3. So you need to multiply by 3. I mean, raise your power to the 3. And that cancel out. So you have x plus 3 equal to e to the 6. So x is equal to e to the 6 minus 3. So show your work, okay? Oh, it's a square root, excuse me. I made a mistake, right? This is just square root. Okay, the square root, not the cubic root. This is just square root right here. Okay. So you can sketch this one. Since it's a negative, you're gonna do opposite way. Okay, this is the same as 1/e to the x. That's what that means. When x gets bigger, as you can see, when x gets bigger, the y gets smaller. So that's why it's opposite. This is regular e to the x. This is e to the negative x picture. So you can graph that. That means it starts at 2. So you need to make sure that 2 right here. 2, so this is graph. Okay. Sketch of the graph, you can do that. Okay, if they're inverse to each other, okay? If they're inverse to each other, as you can see through this y equal to x, they have to be mirror image. This graph and that graph has to be mirror image. As you can see, they are. So that's how you know they're inverse to each other. Okay, so this one. This is a little bit complicated, but you just need to do one at a time. So when you do this problem, just to look at this one first. Look at one at a time. Okay, so make it to be 3 different problems. So we're gonna start with derivative of x squared and e to the x. All right, then you're gonna say, okay, I know how to do that. I'm gonna call this to be my f. I'm gonna call that to be my g. So f is equal to x squared, f prime equal to 2x. G is equal to e to the x, and g prime is e to the x. And you're gonna say this is equal to f times g plus g times f prime. So you're gonna say, okay, I have x squared, g prime, e to the x, plus g e to the x times f prime 2x. So I have e to the x equal to x squared plus 2x. So I'm done that part here. All right, now moving on to your second part. Derivative of 2x e to the x. You're gonna call it yourself, same thing again. F and g, and you say f is equal to 2x, f prime equal to 2, g is equal to e to the x, g prime is equal to e to the x. So plug back in here, f times g prime plus g times f prime. So you have 2x times f prime e to the x plus g e to the x times f prime 2. So we're done. So we finished with that part and that part. The last part is just 5, so it'll be 5 e to the x again. So next, the last part. It's just 5 e to the x, exactly same thing. So we need to combine them. So I have this, and I have that. All right. So if you want to, you can rewrite. So you have this, which is the same as e to the x, and then you have x squared plus 2x plus, right here, 2x plus 2, and then we do this plus 5x to the 5e to the x, which is same as e to the x squared plus 4x plus 2, and then you have 5e to the x. Or you can combine them by multiplying them out everything. So if you want to, you can multiply them out, and then you combine with this if you want to. Then you get exactly this one. All right, so just combine them all together. All right, any questions? So in other words, this problem looks long, okay? It looks complicated, but it's not complicated, but it's long. You got the 3 steps, 1, 2, 3 steps, because you got 3 terms, 1 term, 2 terms, and 3 terms. All right, same thing here. This is the one that, you know, just put it into UMB, F and G. So you're going to say F is equal to 5 plus e to the x, and F prime is just e to the x. And we're going to do G to be 5 minus e to the x, as G prime will be negative e to the x. And just plug into your formula again. Oh, by the way, it's natural log in the front. Excuse me. It's a natural log in the front, so I need to do what? I need to expand them first. Excuse me. It's natural log in the front, so I can rewrite it as natural log of 5 plus e to the x minus natural log of 5 minus e to the x. So now this becomes much easier then. Take a derivative of each one. Y prime would be, take a derivative of this, would it be what? 5 plus e to the x. And derivative of this, it will be just e to the x. Same thing here. The derivative of that would be 5 minus e to the x. Derivative of this part is negative e to the x. All right, you combine them, their denominator. So 5 plus e to the x, 5 minus e to the x. So e to the x times this, minus makes plus, e to the x, multiply that. So when you combine 5 plus 5 minus, you just get a what? 25 minus e to the 2x. And then you just multiply them out, and you get a 10 e to the x. When you multiply them out, and when you combine them, you get that. So just do the distributed, and then right here, you follow this part. Right here. You follow this, then you get this. All right, so it's not hard, it's long, it's tedious. You do a lot of algebra, that's all. All right, so equation tangent line, whenever they ask you tangent line, all right, that means you need to take a derivative. That really means you need to find the slope. Find the slope, that's what that means. And they gave you this. So take a derivative of this, and then you plug it in this number as your x and y to find your a and b. Remember, y is equal to mx plus b. So you find your m by taking a y prime. Find your b by using this point. All right. Okay, the same thing here. Okay, find the relative extrema and point of inflection. So you need to take a derivative, right? Find the extrema means you take a first derivative, and then what? You set them equal to 0 to find x equal to whatever the number is. All right. Do you want me to do this problem, or you want me to do it tomorrow? I got 10 minutes. So if you want, we can do this problem together. Do you want to do this problem in separate paper? Yes or no? Are you with me, guys? Are you following me right now? Or am I just doing this problem by myself? All right, anybody have any questions so far? Okay, so you want me to just move on, or you want me to do this problem with you? Okay, I cannot hear you. So I think, let me see, same thing for here. Okay, the figure below shows graphic of f and g, whereas a is a positive real number identified open interval in which the given condition hold for the graph of f and g. So f is increasing, f is decreasing, so you can just look at this graph to figure out what to do. So this is good. That's nothing to do with, just look at the graph and you can figure it out. That means just take a derivative of this to figure out this part right here. So we got that. Okay, so this one is just to make sure that you put u equal to negative x to the 4, and then du is equal to negative 4x to 3, which this is your du. So you can rewrite it as e to the u and du, and you get e to the u plus c. And you can just plug back in. So that's just a simple problem. Okay, so we've done that. It's a simple problem. So I think that's it. All right, so any questions from today's homework or lesson? Is everybody good? So I want to make sure that let's go over one more time about your homeworks. So we're done with this much. I'm gonna finish this tomorrow, and you got 6, 7, 8, which we're gonna finish by next week. So we have no problem finishing everything, okay? But remember, your exam is on 24, and everything needs to be done by 23rd, and you need to start working on this. the final exam review. You need to start on those because your final exam coming from there. So you need to start working on this. Okay, do not just work on your chapter 5 assignments. You need to start working on your final exam review problems because your final exam is on 25th. Okay, so everything is to be done. All right, I'm gonna probably let you guys go if you don't have any questions.